So hello guys. At first I want to introduce myself. I'm Mark Hoffmann from the Data in Motion, and switching to the next slide will not work. One moment. We should do it. I think it's because of the internet. Yeah. My name is Mark Hoffmann. I am from Data in Motion. We are OSGi and model-driven related company. We're doing much stuff with EMF and OSGi together. And we are located in Jena. And today I want to talk about using EMF in a pure OSGi environment. So who of you knows EMF? Okay, great. And who of you knows OSGi? Really great. So, what are we talking about? We will talk about EMF registries, all the registries we need to get EMF work. And we will talk about having EMF in an ordinary Eclipse environment. Maybe that's the environment most of you are used to when you use EMF. And I will short talk about EMF in an ordinary Java SE environment, and then I will show you how our implementation works. It's called Gecko EMF, and it's an implementation of EMF registries in pure OSGi. And we have ResourceSets as a service. We have model isolation, and I will show you some stuff in code, in examples. So, EMF registries, what are they for? I think you all know the registries. There are two kinds, the ePackage registry and a ResourceSetFactory registry. These are the major two. There are many other, but we are much into these one. And they are used for model registration in general, even also for dynamic model registration, which is possible too if you don't want to generate code in EMF. And there are static registries for non-OSGi environments, and yeah, there's a Eclipse extension registry-based registry, EMF registry. And what are these registries for? They are needed to in a resource set when you want to create resources in EMF and you want to load models with a certain package namespace, then the resource and will delegate to the resource set and then will delegate to the registry to find the corresponding e-packages or resource factories. So, how does EMF work in non-OSGi environments? Has anybody of you ever used EMF in non-OSGi environments? One. What you have to do, you have self-registering packages. If you generate code, then you usually call package name e-instance at a certain point. And there's an init method that registers the same package to a static registry. It's self-registering. And on the other hand, you are always, it's always possible to register your e-package by yourself, just on a resource set. You have always access to any of these registries when you're accessing a resource set, just by get e-package registry or resource factory. And then you can register your file extension with your resource factory. You can register content types with a resource factory. You can, register protocols with a resource factory. And that is what you usually have to do when you are in a non-OSGi environment. In the ordinary Eclipse, if you use it in your Eclipse IDE as model, then for you, EMF generates extension. For you, you get a plugin XML in your bundle, which then uses the extension registry to doing all the same stuff in a different manner. So if you are in Equinox, then you don't have to do anything. You just say generate code. You get your model bundle, and everything's fine for you. In non-OSGi environment, you have to do this by your own, and you don't have to forget to register the eCore model. And if you want to serialize XML, you have to also to register XML resource factories. Otherwise, it will not work. So, as I told before, EMF's home is Equinox, the Eclipse IDE. Equinox is an OSGi framework. It's very related to Eclipse. For instance, if you have a dependency, a require bundle dependency to org Eclipse core runtime, this usually means you have Equinox in the dependency tree. And Equinox has an extension registry, and this extension registry reads the plugin XML. This is a file where you can define your extension. This plugin XML, as I told, is generated by EMF itself. If you generate code, and you get all the registration stuff in there. And yeah, EMF usually generates Eclipse-based, Equinox-based projects. So if you're used to work with the PDE, then you get a complete, correct project setup you can work with. There is, in a gen model, there is a possibility to set a OSGi compatibility mode, but it always modifies the imports a little bit in a manifest. That's nearly all. I have to say, EMF itself usually consists of 3 major bundles. You need org Eclipse EMF common, eCore, and eCore XMI for all the basic stuff. And the pure OSGi dependencies of these bundles are nearly perfect. They have a requirement to a require bundle dependency to org Eclipse core runtime, but it's marked as optional. So this is a great gift. If you want to use EMF in other OSGi frameworks than Equinox, then you have always the possibility to use Equinox supplement bundle in combination with a Equinox extension registry. Then everything stays the same. You still have your plugin XML, you still have your extension registry, and EMF works like a charm, nearly. So, why do I want Gecko EMF and not using, for instance, the supplement bundle and using the plugin XML? Gecko EMF at first is an open source project of our company, and the idea behind Gecko EMF is to use ResourceSets as a service, as we are used to use services in our OSGi environment. As I told, we have many products in OSGi, and handling EMF, for instance, with injections, references is very, very easy for us. So that's what we wanted. And what we wanted to was the dynamics from OSGi. We wanted to know when a model bundle comes in and when it goes away. Because this means if the model is unregistered, I cannot serialize, deserialize. I can serialize, but I cannot deserialize the stuff anymore. So this is a very important thing for all our business logic. So Gecko EMF has a small API, which is used for registering packages or resource factories. So we have to do the same like in Java SE or what the extension registry does. And so we have a very small API consisting of 2 interfaces you have to implement. And to give you some help, we have a very basic gen model code generator extension, which overrides the default mechanism that uses JET And there are extensions in the code generator stuff, and you can overwrite certain code or generate additional code and register your own chat templates. That was what we did. We just hooked into the ordinary generate code context menu stuff. But it's very basic. Yeah, and we added support for BND tools. We currently use BND tools, and we wanted to generate additional stuff for that. So, how does it work? We have no Equinox dependencies. We just have the 3 dependencies to the Eclipse EMF bundles. That's all. We have whiteboard-based OSGi service for the model registration. As I told, if you create a model bundle, then we usually use our tooling to generate 2 services. One service component to register an e-package, and the second one to register the resource factories. These are marked as component, as we are used to in OSGi, and then they are the whiteboard services. On the other hand, we have an own e-package registry, which inherits from the default one, and we also have a resource factory registry, which also inherits from the default one. And these both are services as well in OSGi. And then we combine that stuff together in our own registry, which collects all these whiteboard model registrations for e-packages or resource factories. And then we got our own registry. And we have, in addition to that, not only ResourceSet, we also have a ResourceSetFactory to create ResourceSets as we like it. And what else do we have? We have ResourceSets as a service. Our default components register ResourceSets as a prototype service factory, which means you can inject your resources as reference in any component you like, and you get a new instance. And we have all the dynamics of handling registration and unregistration of models during runtime. We always get informed. We have an own custom service which changes its service properties so that we always know if our resource set and our registration or ResourceSetFactory knows what models are available for this resource set, ResourceSetFactory, and so on. Yeah, major features are we have a default registry, as I told now, that contains information of all registered models in my OSGi framework. We have a second one, which is an isolated registry, and this uses the configurator in the config admin, and it's a configurable component. So you just can give this registry a name, and you can give it a target filter for your models or properties or whatever, and then it comes up and only collects these registered configurators, e-package configurators, resource configurator, whiteboard services. We have a configurable dynamic configurator for loading just equal files. It's also using the config admin and the configurator, and you just can say, I have an equal file in this bundle with this version in this path, and then the equal file is loaded, and as a result you get an e-package from it, and this package is then registered automatically. So it's also in configurator service that when it comes up, it will automatically inject it in the isolated registry or the default registry. So this is quite handy. Yeah, we create a ResourceSetFactory service, which is always available. You can use it if you like, but you don't have to. And for a nice handling, we created, as I told, services for ResourceSets, which are prototype scoped. Yeah, and in addition to this, just this framework, we also have additional extensions already available that we are using. For instance, we have a default eObject message body writer and reader that we are using in the JAX-RS whiteboard stuff. We have extensions for registering special resource factories. We use EMF JSON, maybe some of you know it, to serialize JSON out of an eObject. And maybe you know that, for instance, EMF JSON is highly configurable, and we have created an OSGi support for all of these extensions. So, I think I want to show something, and we want to see how this all works. So, is this readable from, yes, it's okay. So, not for me. So, I have some demos. I will just show at the first point how do we use creating a resource set in an OSGi component. This is what we have here. It's very simple. Everybody knows that. We have the component annotation, the component immediate true, to have it started immediately. And we can add some meta annotations, require EMF, which captures all the dependencies from EMF, which is a capability. And this is just a component property name, meta annotation. So we have two possibilities. We just have to inject a ResourceSetFactory. The ResourceSetFactory has just one method, create resource set. And otherwise, you can create just a resource set. So, and in the activate method, we see we load some sample data, which is an XML file located in the bundle. And here we can see how we use a resource set if it's not available. Otherwise, we reuse the injected resource set here and do not use the ResourceSetFactory. Yeah, and then we're printing out some stuff. So I will show it to you. And clear this. So we can see we have a customer info and first name, last name, and stuff like that. So what happens if we change that? Because we have we can run into one problem if we use this. Just adding a reference. It can happen that our default registry that creates all the resource sets and resource set factories is available in the service registry, and but our model configurator is not registered in the registry, so it's not registered in the EMF registry. So we can come to the position where we have a resource set that has no knowledge about our model we want to have. So that's why we added some additional stuff. We added a target filter. So, and we can do it like that. This works currently, but you can run into problems in large systems, maybe, because you don't know if the model is already there. So we will change that now to show what happens if we change the target filter. I have to look. We take the test one. We currently work with a customer data model. So So now we see that our component is deactivated and not activated again, because we cannot fulfill the reference with this target filter. We don't have a model with the name test registered. So, and this is exactly what we want. We want just to have in start our component when the model is available, and we can do that with this. This is a special pattern, but we always know that this reference is only injected if this model is available. So this is one of the best things that we have, I think. And as we see now, the component is activated again, the reference is there, and we can load this customer. So this is just one thing. We also have model isolation. So clean this up. We have here a simple component which uses ordinary service, OSGi service. And when we activate it, we try to load a customer from the service, printing some stuff out, and we try to load products from another model. Maybe I show you that I have forgotten to show you that we have a customer model bundle, we have an order model bundle, and we have a product model bundle. So now we want to combine two models, two different models. Each is registered by itself, and just give it a start. And this is currently the result from our isolation component. It prints out that we have a customer which came from the customer model, and we have a catalog, a product catalog that came from this model. So what happens when we change the code a little bit? We have here now injected a resource set that knows any model. But if we want to have it isolated, just saying we just want a resource factory that is capable with a product model. Then we see here our component is not able to load the customer anymore. It just loads our product. We see here, this was before the change. We had a customer information, and now we don't have customer information anymore. So our models are very isolated from others. I think this is very good stuff. And yeah, what else do we have? We have also the dynamic handling. Sorry. Too small. Dynamic. So I start this one. And what we have here is we try to load our order model, which has no code, just an eCore model inside. And we want to register that. And how do we do that? This is a little bit different. For that, we have a configuration. This is our model configuration, our model configurator. It has the name 3. So when I will show it, it should fail at first. And we type in our model information. Usually you have this information in your gen model. In this case, we don't have a gen model. So, and yes, this is redundant and will be removed soon from our framework. So we have default stuff there, and I recreated some new properties. So the only thing that is important is this one. We say there is an eCore in our bundle symbolic name ECE order model /model/ order, which is ECE order model order eCore. This is the magic stuff. Clean up this. run. And we see nothing. It is not registered because the configuration is wrong. We have a configuration PID named model configurator 3, but the system only hears for configurator instead of 3. So to see if something happens. Oh yeah, something happened. We now see that it loads in order, even from a file, which is located here. So this is our stuff, and it's not very complex because it's using OSGi. We mainly use the components and the classes that are already available in EMF. We don't edit much own stuff, just the configuration, handling, and things like that. So it's very pure OSGi and it's very pure EMF. And maybe I can show you another stuff where we use it, for instance, in JAX-RS. We have a simple OSGi JAX-RS whiteboard. In this run file, we have a simple resource here, which says hello, and we have a second one which creates an e-object. And what we want to do is just to see how our message body reader or writer, for instance, works. And so I will start this. So now we have to open a browser, one moment. So when I reload this resource, we can see we have an XML here. So we just return in our resource, we just return the customer entity, and our message body writer knows anything about e-objects. And it serializes this customer into XML, into XMI, and it's also possible to have this will not work here. We also have JSON here. When we change the resource, one moment. Just have to say produce JSON instead of XML. So, and if we now reload with we have JSON. It's very handy, and it works just by giving the content type header and accept headers in your request, and then we can serialize the data. And because we are using EMF JSON, for those who know that, we can also serialize YAML, Java properties files, just with a simple extension. But it's not only for the message body reader and writer, we can use it everywhere. We also have an adapter for MongoDB, which then serializes e-objects plain into BSON and stores it in a MongoDB. And even on the other hand, we have a request model for requesting data from this database. So directly from the Mongo database, using a Mongo database codec in the driver, just what comes out are just e-objects. So this is the stuff about Mongo, about Gecko EMF. So, are there any questions? Should I show? Yeah.
What about the ENF edit and the adapter factory? Do you plan to convert it, or do you already convert them?
So sorry?
What about the EMF.edit plugin and the ResourceSetFactory?
Yeah, yeah. Not implemented yet. We have not tested yet. I have to say we use this currently as a basic stuff for our work. We currently don't use the edit framework, but I want to because of all the stack and the commands. And but what we use is, for instance, QVT and OCL. And we have encountered many problems with these projects because of the org Eclipse core runtime requirements in their manifests, which makes it impossible to use it. So we have our own hacks. So we have to be very careful which of the projects we have to use. We can use, but I think the EMF edit stuff, for instance, is quite handy and will work. And I think we will introduce this stuff too. And if you're interested, you can do it too. If you need OSGi help, just ask us, because we always need help. So the code is available for everyone. This is the link to the GitLab project here. So everybody's invited to help us file bugs, recommend improvements, and or extensions. I think it's a good idea. So, do we have some time?
Yeah,
yeah.
3 minutes. Have you scenarios where you use your system standalone and also in Eclipse?
You can use this also in Eclipse, if you like, because it's OSGi. You only need a dependency to this API. Our tooling generates the ordinary Eclipse project you're used to. In addition to that, we modify the project file and class path file to add the BND stuff. We also create a BND file, which doesn't matter if you're running in the PDE. And what we currently not do is adding our API dependency to the manifest. That's the only thing that is missing currently. But if you want to use this in ordinary Eclipse, you can do it. So, but you have to remember that maybe your model is registered twice. If you don't remove the plugin XML, it will be registered over the extension registry implementation from EMF and over our mechanism too. So.
About the level registration. So I guess we can't add a true version of the plugin as well. So you didn't remove the singleton option from EMF.
Yeah, that's the point. If you use it in the PDE, then you always if you use the plugin XML, then every bundle is a singleton. That's not necessary for us. We have a setup where we have 2 different versions of a model with generated code in 2 bundles in the same runtime. And because of OSGi's isolation, you can have both bundles with generated code and you can access both of them. Jürgen has shown a use case at the UC, I think.
Yeah, I wrote it in another blog. Thing is, you can do it if you access them just as a key object. So you use the generated code and directly go to the class of your product or whatever, then obviously it will favor some form of class loading help. But if you use it in a reflective manner with QVT or something like this, then it's totally usable.
Yeah.
You have a couple of versions in your system.
Yeah.
So in the generated code, you remove the director commit, the package,
No, we use BND for packaging the jar, and BND does not use the generated manifest. The manifest in BND, the manifest is generated from the bnd.bnd file, and all the informations are in there. And in this file, we have our setup to export all the stuff that is necessary. And
if you'd like to do it in PDE, you can just remove the singleton
yeah.
manifest and use our
this is quite easy. Our problem currently is that our tooling is based on this gen model OSGi compatibility field. If you set it to true, then our code generator generates the BND stuff and generates the configurator for the e-packages and resource factories. So because we don't have any other possibility currently in the gen model to determine, oh, this is a guy who wants to create a BND, or this is a guy that wants to use the Gecko EMF, just by having a tag, for instance, there. So we wanted to talk with at Merckx about it, and maybe this will happen soon. So at first step, we wanted to avoid to create another option for generating code in EMF. We always have these three options: generate model code and edit an editor and test code, and we just wanted to hook into this and use the available extension that EMF already provides. So.
Okay, so well, we're out of time. Just before we wrap up, I'm sure Mark will be here